We got a weird phone call from NASA recently. They said, "Hey, can you make a video about gravitational anomalies?" And we're like, "Yeah, sure," but it turns out they didn't have any specifics in mind. So we're going to use our imagination and try to figure out what gravitational anomalies are and how they might work. And then we'll talk about some weird stuff that happened when NASA's Juno probe visited Jupiter. The way we usually think of gravity comes from Newton and Einstein. If you've got a planet that's a perfect sphere, which is what Earth should be because it's a big ball of gooey rock and gooey water, then the gravity coming from all directions will be even. That means if you were to drop a weight on one side, it would accelerate straight down towards the center of the Earth. We also know that doesn't happen because we have dropped weights on one side of Earth before, and they do and fall straight down. They fall towards each other. If you had a big space station orbiting Earth and you put weights at opposite ends of it, the weights would accelerate toward each other because Earth's gravity was pulling them together. In fact, you could keep them in orbit around Earth just by having those two weights attract each other. You wouldn't even need rocket fuel. If you had a third weight and you put it somewhere in between the first two, it would accelerate towards the nearest weight, but the Earth's gravity would pull it back towards the other. Eventually, it would come to rest somewhere in between. So, why did NASA call us with this weird question? Well, it turns out that's not always how gravity works. Let's say you had a planet that wasn't perfectly spherical. Maybe it bulges at the equator, or maybe it has a giant volcano on one side. Then the distance from the surface to the center of the planet would be different depending on where you measure. And since distance is part of the gravity equation, you get different amounts of gravity depending on where you measure. Now, let's say you're not on the planet, you're in orbit above it. Because the planet isn't perfectly round, there will still be places that are closer to the center than others. So the gravitational pull of the planet will be stronger in some spots and weaker in others. As an object in orbit falls around the planet, it will speed up as it approaches the part with stronger gravity and slow down as it moves away. That means it won't form a perfect circle, but will trace a path that's lopsided. That's a really bad explanation of what happens. And we're pretty sure we're wrong about a lot of it, but that's the idea. Gravity depends on mass and distance. If either of those things changes, then so does gravity. And as far as planets go, Jupiter is kind of the opposite of Earth. It's a gas giant without a solid surface. No one knows exactly how its gravity works, and scientists have been trying to figure it out for decades. But in 2017, NASA's Juno spacecraft came through and started dropping weights on one side of Jupiter and watching what happened. Scientists thought that because Jupiter is round, the weights would fall towards the center. But instead, the weights did something weird. They fell towards each other, and that's not what they expected to see. The reason that doesn't happen on Earth is that the Earth's gravity pulls objects towards its core no matter what. But according to Newton, Jupiter's gravity shouldn't care about the difference. All it should care about is the overall distance between the weights and the center of the planet. Juno collected more data, and eventually they found out why the weights weren't falling to the center of Jupiter. It's because Jupiter isn't perfectly spherical. It bulges at the equator. There's a centrifugal force that pushes outward as the planet rotates, and that force actually makes the planet wider at the equator than it is tall from pole to pole. So the weights aren't falling towards the center because the center isn't really the middle of the planet. This would be a good time to mention that when we talk about the planet Jupiter, we are not talking about the star Jupiter. There is a star out there somewhere that is called Jupiter, but it's a red dwarf, and it's very far away. Don't worry about it. We're talking about the planet here. The thing is, though, that Juno's observations of Jupiter's gravity suggest that the planet isn't only lopsided, it's also swirling. Scientists say that if the weights had fallen towards each other just because Jupiter isn't spherical, they would have fallen towards the closest point on the planet's surface. But instead, the weights fell towards each other no matter what direction they were initially moving. and that suggests that the surface of Jupiter is sort of sloshing around. It's hard to imagine because we're used to thinking of planets as solid. But because Jupiter is made of liquid and gas, it's more like a giant blob. And that means there may not be a distinct center. If the inside of Jupiter is always shifting, then what scientists thought was the center might actually be the average position of the interior over a long period of time. According to Sean Toomey, who's a planetary scientist at the University of Berlin, that could mean the inner layers of Jupiter are sloshing around faster than scientists previously expected. That's not great news because it raises the possibility that the entire planet is unstable. Sean says that if you disturb the inside of Jupiter enough, it could collapse and change the planet's mass distribution and its gravitational field forever. Maybe it's too late for that because Juno has already disturbed Jupiter's gravitational field a lot. According to Emily Sanford, who's a planetary scientist at the University of Berlin, Juno has dropped over 400 pounds of weights on Jupiter, twice as much as scientists expected. And while they don't think that's enough to collapse the planet, they do think it is possible that all those little disturbances to Jupiter's gravity could add up over time. At the moment, it's impossible to say what's happening inside Jupiter. All we can do is observe the weights falling in orbit and use that to draw conclusions. And it's possible that there are other forces affecting the way the weights fall, like the magnetic fields coming from Jupiter's moon Io. But one thing we do know is that these falling weights are giving scientists a much better understanding of what's going on inside the planet. You know, because Juno's mission was extended beyond its original duration, it has planned to keep observing Jupiter until at least September of 2025. And there's a good chance that we learn more about the planet's gravitational field during that time. So it is possible that scientists will be able to tell whether the inside of Jupiter is truly unstable and what the long-term effects of Juno's mission will be. And hey, maybe they'll find evidence of intelligent life, or dark matter, or black holes. Who knows? Space is neat. By the way, if you want to help us make more videos like this one, you can join our community on a crowdfunding platform. You can get cool perks like submitting a question to our inbox, like this one from a community member. They asked, "How do I explain quantum mechanics to my cat?" This is a tough one. Quantum mechanics is not easy to understand, even for humans. It's probably not necessary to try to explain it to your cat. Cats live in the quantum realm. They're dead and alive at the same time. They can be in multiple places at once. If you're trying to understand quantum mechanics, it helps to remember that cats are not particles. A cat is Schrödinger's favorite thought experiment, but it's not an actual particle. Your cat is definitely real. And if you're trying to understand quantum mechanics, then your cat is probably not the best subject. Try a human, or better yet, a human who understands quantum mechanics. Thanks for watching.